Good afternoon, class. This module in this week, we're talking about the difference of t-tests and confidence intervals and how to apply them to real world application. And I find this to be pretty awesome because I was actually just going for an interview yesterday for a company that's having a lot of issue with efficiency and working on Kaizen theory and going through value stream mapping and how they can use statistics to help their production line. So I think it's really, really key to look at this stuff. But specifically for the first question, we're going to discuss the difference between t-test and confidence interval as valid techniques to test and evaluate the effect variables and to measure. So what we really need to understand about t-tests is you're going to be testing, your null hypothesis to an alternate hypothesis. And with a confidence interval, you're not really going to be doing that. So your t-tests are very much hypothesis related, whether your hypothesis is going to be true. If you reject your null hypothesis, you have to accept your alternative hypothesis. So they're equated in p-values, and you accept your null hypothesis based off of that. And your confidence interval, you're looking for a range or an estimate that it's going to fall in. I'm 95% confident that my values are going to fall within this range, so I know my data set is true because it falls within a certain range. If it falls out of that range, then you're going to start looking at things a little bit more and find something statistically significant if it falls outside of that range. So the important thing to note between the two is t-tests involve a lot of hypothesis testing and confidence intervals. You're looking for a range of numbers. Does it fall within this range or does it not? Now, largely equated with that, t-tests generally deal with smaller samples because it's easier to look at a small amount of numbers to test a hypothesis as compared to a large amount of numbers. So confidence intervals generally deal with a larger set of data than t-tests. Now, the second issue that we come to is discuss the reasons you might use one over the other and summarize the prevailing arguments for and against the use of t-tests versus confidence intervals to decide if there's a significant difference between the sample of means. Now, confidence intervals deal with a larger set of data, and it's using general information to find out what data falls within that range. And there can be a lot of difficulties associated with this. There's your original data that gave you the range correct for what you're actually testing. And then it depends on what kind of data you want to get from things. T-test would be a great correlation for efficiencies within industries. And looking at the difference of means. And there's different benefits for each. And the t-test, I think you really have to look at the bell curve for a lot of this to determine. So if you realize, it's really hard without drawing it. But if you're looking at t-tests and we're talking about the differences, right? And you look at the standard bell curve, and then if it's one or two-tailed, whatever section that your p-value falls within, that's what you're looking for your t-test, your p-value of the sections outside of the normal standard deviations of the less than 5%. In confidence intervals, you're looking for something that's within that 95% range. So realistically, there's not a significant difference, but there is a lot of differences and nuances that go along with it per design. But I really wanted to articulate on that, especially with the bell curve, to give people more of a visual representation, because most of the videos I've been watching in this discussion post talk about, how, hypothesis are associated with t-tests and confidence intervals fall within a range. Well, what does that mean when you're actually looking at data, right? So it's important to realize the bell curve when talking about t-tests and what you're looking for with inside that bell curve to be able to reject or deny your hypothesis, or realize if your data is accurate or not accurate or statistically significant, whether if it falls in a correct confidence interval. And now, providing an example from a real life situation to summarize and discuss. Now, I want to bring up my interview because a lot of questions that I was asked, they had a lean engineer, and I've gone through Lean Six Sigma Black Belt. So I think this class is a wonderful refresher of some great knowledge. And an example that I could use is they're having a lot of efficiency problems. They want to meet 240 productions on a certain production line, but they're having difficulties meeting that. So how do you determine what's going to make that production line more efficient, right? And a lot of it you could do a t-test correlation. If I change this around, or I move this component or this machine in a different location, does that change the amount of time? And then you would take data sets based off of that, and then you would say that you would use a hypothesis. Changing this machine location saves me time on the production line to be able to produce what we want to produce every single day. Or the alternate, it doesn't help me improve efficiency. So, you'd obviously take the correct sample size based off of effect and the power, and then move through, the difference of means, which is what we've been doing for the past little while. Now, confidence interval, a little bit different. And running through the confidence interval, you'd be like, well, I'm 95% confident that, the efficiency within this line will be improved if, we change the location of this machinery. And real life situations for this, I find it to be incredibly applicable, especially in the aviation industry. Everybody's looking for more ways to be efficient, and lean manufacturing and all of this has come about significantly, and there's a lot of industries focusing on it, and to be able to understand that is very important. So anyways, I hope you guys enjoyed my discussion post this week. Sorry about last week. I didn't realize that I still had my headset plugged in, so if it was a little bit quiet, I hope this one's a little bit better for everybody. But everybody have a good weekend. Bye.